Hello, welcome. This is Math 1. Today is the 21st of October, 2019. Solving systems of linear inequalities. What is the learning goal, Bradley?
I can create and use linear inequalities and graphs to model real-life situations.
And then Presley, why?
Life is rarely equal. I want to be able to use the concept of greater than and less than to solve my problems.
Excellent. You've $12 to spend at the snack bar. Sodas cost $1. Candy costs 75 cents. We could create the equation and graph this. And we would shade underneath the line to show all the possible solutions. That's what we did last week, Friday. But today, we're going to add an extra level to it. Oh, but you promised your friends you'd buy them sodas. And you've got 3 friends. You promised 3 of your friends that you would buy them at least 1 soda apiece. So I need 3 friends. 1, 2, 3. I make a promise to you. I'll buy you at least 1 soda. At least 1 soda. At least 1 soda. Could I buy you 2 sodas?
Yes.
Could I buy you 2 sodas? Could I buy you 0 sodas? No, because I promised at least 1. So when we add that second level onto it, how does that affect this? That's what we're looking at. Sodas, chips, but there's another layer where I'm promising sodas to people. First question, what is a system? I get that for you. What is a system? Okay, how about this? Give me examples of systems outside of a math context. System. You've heard the word system. Give me an example of a system. A computer system. Okay.
A sewer system?
A sewer system. We don't normally call it a refrigerator system.
The water system?
Okay, a water system. Okay. I don't think you've really ever said electricity system though. Can you find the word system that you've actually used in life? Yes.
Like
A system that you are really comfortable talking about.
organization system? Organization system.
Go for it.
Government has a good system?
I beg your pardon?
The government has a good system?
What does that mean? So if you're using the word system, I need a system that you can explain to me, not just put the word system behind something.
It works well. If the government has a good system, it means like our government.
That's not what system means.
Like kind of like in a way, like an association in a way.
So far, the best one I've heard is a computer system.
Programming system.
Interesting. So we have this word, and Mr. Best, you need to watch this because we had a conversation about this, that reading comprehension, you guys have these words that you think you know, and yet you can't really tell me what they mean or how they work, or give me an example of it. Go for it. Why is a computer system, what makes a computer system a system?
A system would be like what makes something work.
It's not the definition of a system. Give me an example of a system that you fully understand. The multiplication system? What makes it a system?
The types of stuff working together to get another solution.
Okay, stuff working together. Give me an example of a system.
Like the computer system, all the key parts working together to make one thing.
That's why it's called a computer system. It's got a bunch of pieces to it that are working together. Beg your pardon? But do we use that? Do you call it a phone system? I'm trying to look for the word system that you have used in your life. So, a computer system. Who has a gaming system? Would you have called it a gaming system? Okay, then who's ever heard of a solar system?
Oh, wow.
Would you call it a solar system? Oh, why is it called a system?
Oh, Because all of the planets are working together to. Oh.
Got it.
I got it.
It's called a system because it's got multiple pieces to it. It's got a sun. There we go. Does anybody have, I'm going to throw out some other systems that maybe you've heard of, maybe not. The digestive system.
Oh my
Wait, I have
Wait.
one more thing.
Oh, you've heard that one.
Yes.
What makes it a system? Raising a hand.
I like the organs.
Right, it's multiple, it's not just one thing, it's got multiple. How about the cardiovascular system? Okay, that's another system with, what is it?
The respiratory.
The respiratory system. It includes things like the lungs, probably the brachia, the little things inside the lungs, the esophagus, I don't know, no,
My mom's a respiratory.
the windpipe, whatever that piece
What
is.
about the metric system?
The metric system, it's got multiple pieces to it, right?
Yes.
It's got the meters and the centimeters, it's got all these pieces. So, do you have another system for me? The legal system. Maybe? No? Okay. I'm throwing out ones that maybe you've heard. Legal system. Judges, police, juries, all part of a system, the legal system. Here's our official definition we're going to be using. A system is two or more things working together. A system of linear inequalities is two or more linear inequalities on the same graph. I need this and this in your notes. System, system.
Just those two. Or the three?
I don't need the middle. I need the top sentence and the bottom sentence in the notes. Take your piece of graph paper and fold it to make 4 boxes. In the top 2 boxes, create coordinate systems. I will get you a ruler. Ruler? Ruler for you? Ruler? Ruler. You've made 2 coordinate systems. Here are 2 different equations for 2 graphs, Chris. This one, open or solid or dashed? Dashed. Where does Liam want to start his life?
He wants to start
And how's he want to move, Nico?
up
Down 1 over 2.
Good. This one, raising a hand. Gavin. Thank you for not raising a hand. Where's
-1.
He wants to start at -1. How does he want to move?
Down 3 over 4.
Down 3 over 4. Solid or dash?
Dash.
Graph both of these.
Go.
There will be shading. I recommend when you do your shading, go easy on it. Don't get all crazy. Don't turn it into a mess. Nice. Dash lines. Beautiful. You don't. Okay, you're good. Good. Dash line. Ooh, did you feel that? That was crazy, man. You just you shocked me.
No.
You shocked me. Nice dash shading under. Figure out your shading on that one. You're being crazy. Don't just too much time shading. Don't spend so much time on the shading. Good. Give me the dash. All right. Jackson, can you go up and graph a blue line then?
Sure.
actually, I'm changing my mind. Will you do red?
Just get the top.
You're spending too much time numbering and shading. And don't go double scale on it, just use one box for each. You see what you're doing? You went 1, 2, 1, 1, 2, 2. This should be 1, 2, 3, 4, 5. But on this one, you have to stick with the same scale, otherwise it won't work. All right, good.
And then.
Okay, so starting at -1 and down 3/4, I'll get the ruler out. Dash
Wait.
line. Is that good?
Yeah.
Let's see. They line up, we're good. How are we looking with this one, folks? Okay, dash it. Good. Above or below?
Oh, so above.
Above? Okay, well, let's check it.
No. Yeah, it was above.
We'll see. 0, 0, 0, great.
Zero is
0.
greater than
0
Wait,
is
it's
negative
greater
1.
than negative.
Negative 1. 0 is greater than -1. True or false?
True.
True. So I'm shading on this side of it. Notice I'm not getting crazy with my shading. So good. Red line. You got it, Greenlee. Come on. Oh, sorry. That was I messed it up. Oh, here. There. Is that better?
Very much so.
Nice. Greenlee's putting a point at 1. She's going to do some right. Ah, okay. Gotcha. She's got it going. It's a negative slope. It's looking good. Cool. Solid or dashed? Dash it. Yes. Are you doing the insurance commercial? Is that what you're doing? Oh, man. For at least a decade, I've had that happening. Okay, we're good. And where do you want to shade? Above or below?
Below.
Below. The 0 is less than 1. That's true. So below it. Good. So those are the 2 graphs you have. Here's the deal. This guy by itself is not a system. This one by itself is not a system. But when I take these 2 things and I do them on the same coordinate system, I now have a system of inequalities. You're going to create another coordinate system. Before you do that, stay focused on me for just give me a little bit more time. You're going to take this and this and put them on a third one. Here's how you're going to do your shading though. When you graph this, I just want you to put a couple of little arrows. Don't shade it, just a couple little arrows to tell you, oh, this is the region to shade. Don't shade it. Then graph this one. Yeah, put a couple of little arrows. Just to tell you, this is the region to shade. Those arrows are going to be pointing to the official shaded region. It's going to break it into 4 regions. One little region actually gets shaded. See if you can make it happen. spend so much time numbering things. Yeah, it's good. It's not wrong. It's just I don't want to spend the time doing it. Draw the line in. Actually, draw the lines before you get too crazy with the arrows. Draw them how they are dashed. They're dash, dash. Dash, dash. Okay, so where is the region where the overlap would have occurred? Okay, this one says shape right, this one says shape right. This is the region that would shape right. You got it. Actually, you got it backwards. This one right here. This is your blue line, and it's saying shade under. If this was red, it's saying shade over. So if you did those arrows on it, it would be pointing to this region right here. That's the shaded region. It's where the yellow, excuse me, the red, it's hard, and blue would come together and make a purple. Good. So it would be. So you know she love this line right here? That's the blue line. Well, so you got an arrow on this one. You got stuff mixed up. So figure out. Well, you got. Okay, make them smaller because now I don't know which line this thing is going to. So if you look at mine, little arrows that aren't going too far back. Good. So notice this is the region where the arrows are trying to tell you to shape. Shape this region right here. Those are the solutions right there. Shade that region. It's going to make sense. I'm hoping it's going to make sense. So all these little arrows are telling you, hey, this is the spot, this is the spot, that's the spot. Shade that area. That's where it all works. Perfect. Good. 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 So here's what it looked. Here's really good like where you shape that. It's good. When I take the red and I take the blue and put them together, they end up overlapping in this region. This is the region where the points work. What does it mean to be a solution? If you plug it in, it will work. If I take this point right here and I plug it in here, will it work?
Yes.
Yeah.
Will it work here also?
Yeah.
This is where it works for both equations. Here, these points only work with which color?
Red.
Red. These only work with blue. The ones over here work with nobody. These are the ones that work in both inequalities.
So, like, would you combine the equations then or no?
I don't, these two equations are completely separate. They do not combine the shaded regions. The overlapping region is the solution. Kind of an analogy for this is, think of it as a door with two locks. In order to get inside, both locks have to work. Here, the red lock, the red key works. The key works in the red lock, but not the blue lock. It works in the blue lock, but not the red lock. Here, it works in both of the locks. You've got to be able to find this area where it works for both of them. And that's that region. Questions? It's just doing what we did on Friday twice and figuring out that region where it all comes together. We're going to do one more together. Create a new coordinate system for me. Will you graph the blue line and nothing more than the blue line? Blue line and stop. Blue line and stop. Is it solid or dashed? Solid, okay. Blue line and stop.
again?
It did. So this is a mini-me equation. So I'm going to break it up. I'm going to go 2x equals 8. And 4y equals 8. That gives me x equals 4, y equals 2. X equals 4, y equals 2. Solid or dashed?
Solid.
Do you want me to shade above or below that line?
Below.
How do you know it's below Aiden Fisher? Because what?
We're supposed to.
You're supposed to do the blue line. I just did the blue line. Am I shading above or below? What do you say?
Below.
How do you know it's below?
Because if you plug in just one of those points, in that case I plug 0, 0.
Okay, plug in 0, 0.
And it was less than 2. So
Is this true or false?
True.
This is true, which means this point is
Correct.
true, which means I shade.
That spot.
Okay, just a couple little arrows, nothing crazy. Small little arrows just telling you what side to shade. Graph the red line. Sounds like a subway system. The blue line, the red line, the green line. You guys don't know what I'm talking about. I've never left you covered, Mr. Barre. Well, in other states, not other states, other cities, there are these trains that go underground. They're called subways. You've been on a subway? Where?
New York.
I've been on the New York subway.
My cousin lost on
Yeah, subways are
it.
tough
Right when I
sometimes.
stepped out, she was still in there. Closed the doors.
Who else has been on a subway? Raise a hand. Which one? Gavin?
I forget.
Karen, which subway?
It was in Los Angeles.
Yeah, LA has a subway and it also goes above ground sometimes. Yep. Where? Oregon? Which, like Portland, you think? Portland. Any other subways? Yes? Have you been on another subway? Let's see. I've been on New York, LA, San Francisco.
Oh yeah, I didn't know.
Oh wait, yeah. I've been-
Paris.
I've been to San Francisco.
The BART.
The BART.
That's what it's called. Bay Area Rapid Transit, BART, BART. Moscow. That one is underground. Like you go down and down and down, down. And you're getting down there like, ooh, what's down here? There's like oil seeping up. No, not really that far. He's gonna pat his head. All right. This is a Liam. Where do you want me to start my life? Where does Liam want to start his life?
2.
At 2? How does he want to move?
Up 1 over 2.
Solid or dashed?
Yeah.
Dash.
Okay. Have you guys thought about the shading?
Yeah.
Yes.
Yeah.
Above or below?
It's above.
Above? Okay. I'm going to check that aboveness. 0 is greater than 0 plus 2. 0 is greater than 2.
Wait, did I? Hold on, wait. 0. I thought
0?
it was 0, 0. So it's not. Oh. No.
So-
Wait. Oh. I
So
must
if
have did
this
wrong.
is, so I'm looking at this line and 0.
Yeah.
0 is false. So where do I shade?
Up.
Above.
Oh wait, yeah, I did that right.
So where does it all come together?
Oh right.
Right here?
No.
Right here.
No.
Right here.
No.
Right here.
No.
Right here.
No.
I could do this all day long. Right here?
No, it's the.
No.
Right there?
Yes.
Gotcha. That is the area where those points, they work in both equations. This point works here and here. Over here, what about this point?
No.
No.
Does it work in either of them?
No.
It,
No.
notice this is, nothing is in this region. This is like half of a solution, this is half of it. This works in blue, this works in red, I think. This works in purple, in both of them. This doesn't ever work.
Clear.
Doesn't unlock any lock. Unlocks the top lock, but not the bottom. Unlocks the bottom, but not the top. Unlocks both of them. I'm going to stop there. I have more that we could do, but there it is. Here. Mini-me, Liam, figure out the shading. This one, don't trip out on this guy right here. What's the slope right here?
0 or wait, 1 over
1 over 1
plus
and plus 0. This guy, this is x equals 0. X equals 0. Well, this is x equals 2, x equals 1, x equals 0. This is x equals 2, x equals 1, x equals 0 is just that line right there. Vertical lines, x equals 3 would be a vertical line like that. Y equals 4 would be a horizontal line like that. We've done some of those before. Okay, question?
So the x is greater than equal, is greater than 0, the line goes over 0.
So you'd have to pick a point besides 0, 0 to test. You'd have to test 1, 1
Or 2, 2.
or 2, 2. You've seen that before. If it goes through 0, 0, test a different point. Done. Start it.